In this video, I'll be reviewing chemical bonds. And I talked about chemical bonds before. I made a video on bonding before. But I wanted to add to that information some of the new concepts we've been talking about, like electronegativity. Just because it'll be helpful, because I'll be making a video on Lewis structures soon. So it's good to know more in depth. So, a chemical bond is simply an attractive force. Between atoms, ions, molecules, whatever you name it. And there's three types of different bonds: ionic bonds, covalent bonds, and metallic bonds. Some people don't consider metallic bonds as a different bond, but it's good to know that it exists. So in this video, I'll just talk about ionic bonds. I'll talk about covalent and metallic in the following videos. So, ionic bonds. I defined it before as electrostatic attraction. Between oppositely charged particles or ions, between something we call a cation and an anion. A cation and an anion. This is negative and this is positive. And sometimes people just define it as a bond between a metal and a non-metal. That is true for binary species, but it's better to define it as a cation and an anion, because sometimes nonmetals can act as cations, not only anions. So, just to review just to combine it with what we talked about electronegativity, we said that electronegativity increases like that and like that. Therefore, fluorine is our most electronegative atom, followed by oxygen and chlorine. So increasing, this is increasing, this is increasing. Now, as I said before, some people say that an ionic bond can occur and usually occurs between a metal and a non-metal. And we said that this is a barrier between the metals and the non-metals. So, considering our trend of electronegativity, that means that our metals will have a very low electronegativity, I'll just call it En, and non-metals a high electronegativity. So our metals will be cations. So let's go with Na+. And our non-metal will be an anion. So Cl-. You can see a negative and a positive. And when you combine them, the difference in electronegativity will be very high, because one will have, let's say, the non-metal we have like a 3.6, let's say, and the metal will have like a 0.2. So we have a very high electronegativity. I'm just making up numbers, so don't follow it up. So when we have such a high electronegativity and the barrier is put in a difference of 2, so when this is 2 or more, we say we have an ionic bond, just considering electronegativity difference. And one thing I forgot to mention, when you're considering an ionic bond, there's no sharing of electrons. The electrons will flow from the cation to the anion, and that's it. They won't share it like in a covalent bond. This looks bad. No sharing of electrons. And this is very important when you consider drawing a Lewis structure, because you can draw something like this. This is wrong. This sharing here doesn't exist. So that's why you would only write it as something like this. This line right here represents sharing. So that's a good introduction for Lewis structures. So when you consider an ionic bond, it's only electrostatic attraction between two different ions. And if you're able to compute it, and the electronegativity difference is more than 2, then or equal to 2, you will have an ionic bond. Some people say it's 1.8, but 2 is more broad. Just to show you how it works, let's say you can find the different electronegativity values for each of the elements online. And let's say we have a bond between the potassium ion and fluorine. Potassium has an electronegativity of 0.8, so 0.8, and fluorine has the highest electronegativity, and that's 4.0. No element will have an electronegativity higher than 4.0. And well, in case you were wondering, francium has the lowest with 0.7. So it's really a difference from 0.7 to 4.0, highest and lowest. So going back to our problem, there will be a bond formed here. We'll have Kf, and the difference here will be 3.2. That is higher. That is not equal. The difference is higher than 2, so you can consider this an ionic bond. So it's pretty simple. And so you don't get confused, you see hydrogen in the left side right here, but it actually has an electronegativity of 2.1. So it's kind of in between. So don't think because hydrogen is close to it's in the metal section, it'll have a very low electronegativity. It actually has an electronegativity of 2.1. And that is it for ionic bonds. I'll be making a video on covalent and metallic bonds after this one. If you have any questions or problems, or you want a video made on something, be sure to send us an email. And if you found the video helpful, please like it and share it with your friends.